We'll start in 1 minute. We'll continue reviewing for the final exam. We'll finish the paper practice final exam and then look at some application problems. So a reminder, the final exam is on Monday, November 30th, from 3 p.m. to 5:15 p.m. Mountain Standard Time. You'll be taking the final exam on Newton, but you need to join the Zoom meeting before you start the final exam. I'll send a link for the Zoom meeting a day or two before the final. And another reminder, the student evaluations on Moodle are due today. Okay, picking up from where we left off, we were solving this rational inequality. And we got to this stage, x plus 7 divided by x minus 7 is less than or equal to 0. And so to find the endpoints of the intervals, the x value that makes the numerator 0 is -7. So -7 is one of the endpoints. The x value that makes the denominator 0 is +7. So we plot those numbers on the number line. -7 is to the left of +7. And those two numbers divide the number line into 3 separate intervals. Pick a test point from each interval. From the first interval on the left, we can pick x to be -8. And then in the inequality, replace every x with -8. So -8 plus 7 over -8 minus 7. This is -1 over -15, which is +1/15. The inequality, though, is less than or equal to 0. And this inequality is false. So that means none of the numbers from -infinity to -7 are solutions. In the second interval, pick a number between -7 and 7. We can pick 0. Replace every x with 0. We get 0 plus 7 over 0 minus 7, which is -1. The inequality less than or equal to 0. This is true. And then the third interval, pick a number greater than 7. I'll pick 8. And then in the inequality, replace x with 8. So in the numerator, 8 plus 7. In the denominator, 8 minus 7. Or 15 over 1, or 15. But 15 less than or equal to 0 is false. So none of the numbers in the interval from 7 to infinity are solutions. And then the endpoints, any x value that makes the denominator 0 is never part of the solution set. So 7 is excluded. The other endpoint, -7, that makes the numerator 0 and the denominator non-zero. And that's fine. 0 less than or equal to 0 is true. So we do include -7. So include -7, but exclude +7. Okay, the algebraic notation is -7 less than or equal to x, which is strictly less than 7. That's the algebraic notation. The interval notation is bracket -7, comma, +7 parenthesis. In the next example, solve the equation 5 over x plus 3 minus 2 over x minus 3 equals 2 over x squared minus 9. Okay, so the least common denominator, the least common multiple of the denominators is x plus 3 times x minus 3. If you multiply those two binomials, you get the other denominator, x squared minus 9. So we multiply every term on both sides by the least common denominator. So x plus 3 times x minus 3 over 1 times 5 over x plus 3. And then minus x plus 3 times x minus 3 over 1 times 2 over x minus 3. And also on the right-hand side, I'll write the expanded form, x squared minus 9 over 1 times 2 over x squared minus 9. And in each one of those products, we get a cancellation. So here, x plus 3 divided by x plus 3 cancel each other out. In the next product, x minus 3 divided by x minus 3, those cancel. And on the right-hand side, x squared minus 9 divided by x squared minus 9 cancels. And then we write down what's left. We have x minus 3 times 5, and then minus x plus 3 times 2. And on the right-hand side, we just have 2. Okay, so watch out for the signs, positives and negatives. X minus 3 times 5 is 5x minus 15. And here we're going to subtract 2x. And we're also going to subtract 2 times 3, or subtract 6. Okay, let's combine like terms. On the left-hand side, 5x minus 2x is 3x. Minus 15 minus 6 is minus 21, equals 2. Then add 21 to both sides. We get 3x equals 23. And divide both sides by 3, x equals 23 divided by 3. The restricted values are -3 and +3. And since this is not restricted, then it's a solution. But always be aware when solving rational equations. Take note of the restricted values. So we say x cannot be -3 and x cannot be +3. Okay, the next page on the practice final. So graph the parabola y equals -x squared plus 2x plus 3 by using its properties. Okay, so the properties are the x and y intercepts, also the vertex, and whether the parabola opens up or down. Okay, so in part A, does the parabola open upward or downward? Since the coefficient of x squared is negative, it opens downward. What is the axis of symmetry? Well, the axis of symmetry is the equation x equals negative b over 2a. So in this particular quadratic function or equation for a parabola, a is negative 1 and b is positive 2, c is positive 3. So we have the negative of 2 over 2 times negative 1. And when we simplify, negative 2 over negative 2 is positive 1. So the axis of symmetry is the line, the vertical line, x equals 1. Okay, the x-coordinate of the vertex is the same number that we got when we found the axis of symmetry. So the x-coordinate of the vertex is 1 because that's negative b over 2a. And then to find the y-coordinate, we just use the function itself, replace x with negative 1. So we get y equals the negative of 1 squared plus 2 times 1 plus 3. And 1 plus 2 plus 3 is 6. Okay, so the vertex is the ordered pair 1, 6. Okay, next, find all intercepts and write the intercepts as ordered pairs. We can find the y-intercept first. The x-coordinate of the y-intercept is 0. And we can tell just by inspection, in other words, we can tell by looking that when x is 0, y is 3. So the y-intercept is the ordered pair 0, 3. Okay, it's not as obvious what the x-intercepts are. So to find the x-intercepts, replace y with 0 and solve for x. Okay, so to find the x-intercepts, replace y with 0. I'll go ahead and write it. Replace y with 0. And then solve for x. So when we replace y with 0, we get 0 equals negative x squared plus 2x plus 3. And we can always use the quadratic formula. Or another option is to see if we can solve by factoring. In any case, what I would do, since the coefficient of x squared is negative 1, I would divide every term on both sides by negative 1. And so 0 divided by negative 1 is 0. And then the right-hand side is x squared minus 2x minus 3. And in my mind, it's easier to evaluate x squared minus 2x minus 3 than it is negative x squared plus 2x plus 3. So we can solve this equation by factoring. One factor is x minus 3, the other one is x plus 1. The solutions are positive 3 and negative 1. So the x-intercepts, written as ordered pairs, one x-intercept is 3, 0, and the other x-intercept is negative 1, 0. Okay, so we can sketch a graph. We can plot the vertex, 1, 6. the y-intercept is 0, 3. One x-intercept is negative 1, 0. The other x-intercept is 3, 0. By symmetry, when x is 2, the y-coordinate should also be 3. So that's just about enough to graph this parabola. So my graph is marginal, not that good, but you get the idea. We know that it opens down. And the vertical line of symmetry, we usually put a dashed line for the vertical line of symmetry. It's the vertical line that passes through the vertex. X equals 1 is the equation for the vertical line of symmetry. Okay, part F. This is part of the same problem. Solve the inequality negative x squared plus 2x plus 3 is greater than 0. Write your solution in interval notation and algebraic notation. So if you use the graph in part E, then no work is needed. Okay, so on what interval is negative x squared plus 2x plus 3 greater than 0? Okay, the hint is this is the graph of the quadratic function y equals negative x squared plus 2x plus 3. So this is like asking for what x values are the y values greater than 0? So in other words, where is y greater than 0? For what x values? Well, another way to describe the same thing, on what interval of x values is the graph above the x-axis? If the graph is above the x-axis, then the y values are greater than 0 there. So the graph is strictly above the x-axis from negative 1 to 3, but excluding negative 1 and 3. Okay, so the answer in, we're doing part F. It says write your solution in interval notation and algebraic notation. I'll go ahead and write it up here. In algebraic notation, it's negative 1 is less than x, which is less than 3. The interval notation is parenthesis negative 1 comma 3. Okay, but to follow the directions, the answer to part F, algebraic notation, negative 1 is less than x, which is less than 3. Interval notation for the same set of numbers. parenthesis, -1, comma, 3, parenthesis. Hey, if the graph doesn't help you solve this inequality, then you can use the regular method. Find the endpoints by setting -x² plus 2x plus 3 equal to 0 to find the endpoints, and then plot the endpoints and then test the intervals. And we saw some examples of that already. So let's go move onward. That's all of the problems on the sample final exam. So let's look at some of the word problems that I emailed yesterday. So we won't have time to do all of them, but okay, number 1 says Wooster rode his bicycle the same distance in 2 hours as Finknottle rode his bicycle in 3 hours. Wooster's speed was 4 miles per hour more than Finknottle's speed. Find Wooster's speed. That's the same as saying find Wooster's rate. So this is rate times time equals distance. It's a uniform motion problem. So we'll pick a variable for Wooster's rate or speed in I'll say x miles per hour. Okay, so for Wooster, we can write down an equation of the form rate times time equals distance. And also for Finknottle, we can write down rate times time equals distance also. Hey, so let's read this. Wooster rode his bicycle the same distance in 2 hours as Finknottle rode his bicycle in 3 hours. And Wooster's speed was 4 miles per hour more or faster than Finknottle's speed. Okay, so since I used x for Wooster's speed, how do we represent Finknottle's speed? So I picked x to represent Wooster's speed. And based upon that selection, how do we represent Finknottle's speed? We're told that Wooster's speed is faster by 4 miles per hour. So Finknottle's speed is x minus 4 miles per hour. X minus 4 is 4 less than x, or x is 4 more than x minus 4. Okay, so for Wooster, the amount of time that he rode his bicycle was 2 hours. So rate times time equals the distance. We're not told what the distance is, but we are told that they each rode the same distance. Finknottle in 3 hours rode the same distance. So for Finknottle, his rate is x minus 4 miles per hour, and in 3 hours, he rode the same distance, d. Okay, we want to know what x is, so we need an equation whose only variable is x. So since the two distances are the same, we can write Wooster's distance is 2x. That's equal to Finknoddle's distance, which is 3 times x minus 4. Because each one of those is equal to the distance, but the distances are the same. So we end up with a simple equation to solve. 2x equals 3x minus 12. Then if we add 12 to both sides and subtract 2x from both sides, we get x equals 12. So Wooster's speed is 12 miles per hour is Wooster's speed. Okay, the next problem, 50 children and 90 adults attended a movie at the discount theater. The total receipts from all tickets sold was $370. And then two adult tickets and 3 children's tickets cost $12. Find the price of each type of ticket. Okay, so there's an adult ticket price. And a children's ticket price. So let's say the adult ticket price is X dollars and the children's ticket price is Y dollars. And now we can start writing down equations. The total amount of money that was made by selling 50 children's tickets and 90 adult tickets was $370. Okay, so 90 adults each paid X dollars, so 90 times X, that represents the amount of money that was made by selling 90 adults tickets at X dollars per ticket. We add that to 50 times Y. This represents the amount of money that was made by selling tickets to 50 children. And then we're told that the total amount of money made was $370. Okay, we're also given additional information. 2 adult tickets and 3 children's tickets cost $12. Okay, so 2 adults each paid X dollars, so 2 times X. And for the 3 children, they each paid Y dollars, so 2X plus 3Y. And the total is 12. Okay, so we have a system of 2 linear equations. We can use substitution or addition. So I think what I would do in the top equation, notice that everything is a multiple of 10. So if I divide every term on both sides by 10, I can reduce the complexity by a factor of 10. So I get 9x plus 5y equals 370. Oops, not 370, 37. So yeah, this is right after dividing every term by 10. And well, in this process, I'll just go ahead and solve this equation for x and use the substitution. So if I solve for x, I first subtract 3y from both sides. So 2x equals negative 3y plus 12. And then divide both sides by 2, I get x equals negative 3/2 y plus 6. Okay, so in the other equation, 9x plus 5y equals 37, replace x with negative 3/2 y plus 6. So we get 9 times negative 3/2 y plus 6 plus 5y equals 37. And then it's algebra and arithmetic. Okay, so 9 times negative 3/2 y is negative 27/2 y. And then plus 9 times 6 is plus 54. And plus 5y equals 37. Okay, so we'll subtract 54 from both sides. And I'll convert plus 5y to plus 10y over 2 so that we can add it to negative 27 over 2y. So we'll do those two things at once, negative 27/2 y plus 10/2 y, and then 37 minus 54 is negative 17. And negative 27/2 y plus 10/2 y is negative 17/2 y equals negative 17. Then multiply both sides by the reciprocal of negative 17/2. In other words, multiply both sides by negative 2/17. So we get y equals negative 17 times negative 2/17. And this simplifies to positive 2. Okay, so each children's ticket was $2. And we can use one of the other equations to solve for x. If we use this equation and replace y with 2, replace y with 2, 3 times 2 is 6. So 2x plus 6 equals 12. Or 2x equals 6, and x equals 3. So the adult tickets were $3 each. Okay, let's look at the next problem, number 3. Hortensia invests $15,000 in 2 different accounts, one paying an annual interest rate of 5% and the other paying 7%. After 1 year, she receives a total of $930 interest. Find both of the amounts invested. Okay, so one was at the rate of 5%, the other one at 7%. So let's pick x to be the dollars. X dollars invested at 5%. And pick y to be the number of dollars invested at 7%. Okay, we can write down 2 equations. The total amount invested is $15,000. So one equation is x plus y equals 15,000. And then the next equation, each term represents an amount of interest. So altogether, after 1 year, the amount of interest was $930. And so X dollars at 5% per year earns 0.05 times X dollars in interest. We add that to 0.07 times Y dollars in interest, and the total amount of interest is $930. Okay, so there's our system of equations. So we can get rid of the decimals in the second equation if we multiply every term on both sides by 100. So if we do that, we get 5x plus 7y equals 93,000. Okay, so let's try the addition method this time. If we multiply every term on both sides of the top equation by -5, we'll get -5x minus 5y, and -5 times 15,000 is -75,000. Then we add that to the other equation, 5x plus 7y equals 93,000. When we add those two equations, the variable x will be eliminated. -5y plus 7y is 2y, and -75,000 plus 93,000 is 18,000. Then divide both sides by 2, we get y equals 9,000. Okay, then since x plus y equals 15,000, we can see that x is 6,000. Okay, so $6,000 was invested at 5% per year. At 5% APR, annual percentage rate, and $9,000 was invested at 7% APR. I guess they capitalized that. Okay, let's move on to the next problem. It's a mixture problem. A chemist mixes a solution that is 15% alcohol with one that is 32% alcohol to produce 20 liters of a mixture that is 25% alcohol. Find the numbers of liters of 15% solution. Okay, let's all pick X to be liters of the 15% alcohol solution, and I'll pick Y to be the number of liters of the 32% alcohol. And then we can write down two equations. Altogether, we want 20 liters, so X liters plus Y liters is 20. And then in the next equation, we write down terms that involving the percentages. Okay, so since X liters is 15% alcohol, 0.15 times X represents the amount of pure alcohol. And then Y liters is 32% alcohol, so we multiply 0.32 times Y. The mixture is 25% alcohol, so 20 liters, that's 25% alcohol, has 0.25 times 20 liters of pure alcohol. Notice 0.25 times 20, that just simplifies to 5. And we can get rid of the decimals if you want. You don't have to, but if you want to get rid of the decimals, we can multiply every term on both sides by 100. And that gives you 15x plus 32y equals 500. Hey, if you want to use substitution, well, one choice is solve the top equation for x by subtracting y from both sides. So x equals 20 minus y. And then in the other equation, replace x with 20 minus y. So we get 15 times 20 minus y plus 32 equals, plus 32y equals 500. 15 times 20 is 300 minus 15y plus 32y equals 500. Okay, so in the next step, I'll do two things. I'll subtract 300 from both sides and also add negative 15y to 32y. So negative 15y plus 32y is 17y. 500 minus 300 is 200. And then divide both sides by 17. Y is equal to 200 divided by 17. Okay, so in this problem, y doesn't turn out to be an integer. So you would have to use your calculator to get a decimal number and then round it to the nearest tenth. So that's rounding it to the nearest, or to one place value. Okay, since x plus y is 20, then x plus 200 over 17 equals 20. So if we multiply 20 by 1 in the form 17 over 17, and then we're subtracting 200 over 17 from both sides. So we get x equals 340 over 17 minus 200 over 17, which is 140 over 17. So round that to the nearest tenth. Actually, they only ask for the number of liters of 15% solution. So if they only want one of the solutions, make sure that you pick the right one. So based on our variable assignments, we type in the answer for x as a decimal rounded to the nearest tenth. Okay, the next problem, number 5. This one says, Rainsby takes 3 times as long as Claude to mow a lawn. Working together, they can mow the lawn in 75 minutes. Find the number of minutes it takes Claude to mow the lawn. Okay, this is a work problem. Equations have the form rate times time equals 1. Okay, find the number of minutes it takes Claude to mow the lawn. And we're told that Rainsby takes 3 times as long as Claude. Well, there's more than one way to do it. Since we're supposed to find the amount of time it takes Claude to mow the lawn, I'll pick T to represent Claude's time. And then Rainsby takes 3 times as long as Claude. So Rainsby's time is 3 times T. Okay, so we can write down 3 equations, each having the form rate times time equals 1. So they work together, and then they work separately. Okay, when they work together, so Rainsby works at a certain rate, Claude works at a certain rate, and we're told that when they work together, they can mow the lawn in 75 minutes. So rate times time equals 1. For Rainsby works at a certain rate, and 3t represents the amount of time Rainsby takes. So for Rainsby, rate times time equals 1. And for Claude works at a certain rate, and in t minutes, he can mow one lawn. Okay, so Rainsby's rate plus Claude's rate is 1/75, 1 over 75. Rainsby's rate is 1 over 3t. Claude's rate is 1 over t. Okay, so we want an equation whose only variable is t, so replace Rainsby's rate with 1 over 3t. We add that to Claude's rate, which is 1 over t, and the sum of the two rates is 1 over 75. Okay, the least common denominator is just 75t. So multiply every term on both sides by 75t. So 75t times 1 over 3t is 75t over 3t. And 75t times 1 over t is 75t over t. And on the right-hand side, 75t times 1 over 75 is 75t over 75. Okay, then we simplify the fractions. 75t divided by 3t is 25. 75t over t is 75. And 75t divided by 75 is t. And 25 plus 75 is 100. So Claude takes 100 minutes to mow the lawn by himself. Claude takes 100 minutes. and mow the lawn. Okay, we're less than a minute left. We can at least start this one. Daphne rows 4 miles per hour in still water on a certain river. It takes her the same time to row 3 miles upstream as it does to row 7 miles downstream. Find the speed of the current. Okay, so upstream, if we let x be the speed of the current, then upstream, the boat is traveling at 4 minus x miles per hour. And in a certain amount of time, going upstream, she rows 3 miles. And then downstream, in the same amount of time, which is the rate will be 4 plus x times t, she can row 7 miles. Okay, so that's all we have time for today. So that concludes the semester. So just remember the final is at 3 o'clock on Monday, Mountain Standard Time. And join the Zoom meeting before you start taking the test. Okay, but that's all for now.